my tablet. Okay. All right, so, and I'm going to present on my tablet here. Awesome. Okay. All right, so this is the form that, or the screenshot that you should have open up if you don't have it open up already. To have that opened up, and also if you have pen and paper handy, it would be very useful to have that. So everyone have pen and paper?
Yep, I do.
Awesome.
Yeah, give me a second.
Okay. Everybody have pen and paper now?
Just opening, just finding the screenshot.
Okay.
Yeah, I think I might take a picture of this.
Okay.
Make it easier.
Or you can also do this, Ty. You can also take a screenshot of what I have right now.
Too late, already there.
Say that again, I'm sorry?
No, I'm already there, it's fine.
Okay. All right, so we have pen and paper, guys?
Yep.
Okay, and we have the when we have this image opened up.
Yes.
Okay, so this would have been a topic that I would have to that we would spend like maybe another day or two going over, but I promise you I actually don't need to do that much talking to guide you through this, because everyone here has it in them to answer these questions, to solve these problems. Okay, so what's the goal of this? Maybe Michael, can you read the instruction?
Find the area of the shaded region. All drawings are not drawn to scale. Round to the nearest whole number, expressed in terms of pi and in reduced radical form.
Thank you so much. Okay, so just to be clear, for instance, in this diagram right here, do you know what the what is meant by this? What is meant by this D here?
Diameter.
That is the diameter. Those are circles. Okay, so again, I am telling you, and this is actually how, like drafting, like blueprints and the notation is actually just like this, where you where we have these arrowheads and we indicate what the dimensions of the various things are. Okay, so just to be clear, that is the notation. Okay, and what do you think is meant by that intersection there?
Could it be the
Does anyone have any
transversal?
ideas? Say that again.
Could that be the transversal, like what cuts an angle in two?
I agree. I agree with your line of thinking that this vertical line is sort of a transversal, but that's not what I'm going for there. Everyone see what I highlighted in pink there?
Yep.
What's the significance of that
I
point there?
think so.
Is it? Wait, hang on, let me go back to the. Is it the Does it signify like the distance between to the No, I don't know.
Okay, so guys, what do you think this? What do you think? What do you think this shape here is?
An
That is
oval.
no. What do you highlight? That's an arc.
That's an arc. Does it? Well, okay, so that arc there, okay. What does that look like? What kind of arc is that?
It's 180 degrees.
180 degrees. So it's a semicircle, right? And what about this, guys?
Also 180 degrees.
Also 180 degrees. Also a semicircle. So one more time, what is the significance of that intersection then?
It shows where it cuts off the 180 degrees, a semicircle.
That's true. Otherwise, this is known as, again, this line that I'm highlighting in red. What is that known as? Starts with the letter
Wouldn't
R.
that be
Say that
radius?
again. It's a radius.
Radius,
That's right. So therefore, one more time, this intersection, the word I'm looking for starts with the letter C.
Circumference.
Not circumference.
Wait. No, centroid is only for triangles.
So what's the point called where the radius comes together?
When the radius comes together.
Guys, do you see this?
Yes.
That
Yeah.
hold on. That this is actually part of a full circle.
Yeah.
So that point that I was pointing at, what is that known as? Starts with the letter C.
Centroid.
Center. Close enough.
Center, the
So
center.
it's the center. This is
Okay.
the center. Okay? That's the center. Center of what though?
The center of
Of that semicircle.
Of that semicircle. Yeah. That's it. It's the center of the semicircle there, right? It's also the center of this bigger circle. Do you guys see that?
Yeah.
Okay.
Yep.
So the intersection, okay, is in fact the center of those semicircles. So I need you guys just to be clear on the notations here, okay? Just like what's the significance? What is the significance of this of that point there?
It's the center of the circle.
That's
right.
That's the center of the small circle there. Okay, so now that we're clear with the notation, at least knowing how to read it, okay, let's try to answer the question. And as Michael pointed out, right, our objective is to find out what is the area of the shaded, okay? Anybody here have any strategies to help us find the area of the shaded region in diagram number 1?
I would say multiply. We'll find the so we find the area of what's it called? The white rectangle and the green rectangle, and subtract the green from the white.
Exactly. Thank you so much for that, Ty. So the strategy for all of these, as a matter of fact, okay, the strategy is this, okay? So the strategy is we're going to take a larger area subtracted by a smaller area. So when we take the larger area and subtract it by the smaller area, what we're going to end up with is the leftover, right? So that's actually going to be the strategy for all of these problems and for even more complicated problems. So let's go with that. Maybe Kian, what is the area of the small white triangle here?
The area of the small white triangle.
Yeah, how can we figure that out?
Triangle?
I'm sorry, rectangle.
Rectangle?
Thank you, Kian.
The area would have to be 6 or something.
No. So look. So check this out. Look, if you guys are confused on how to read this, right? So you see what I'm doing right now. That 1 foot corresponds to the height of the Small white triangle, right?
Yeah.
What's the width of this white triangle?
It's 2.
It's got to be 2. That corresponds to it. You see that?
Mhm.
Right? They correspond. All right. So with that said, what's the area? What's the area of the small white rectangle?
That's be 2 feet.
It has to be 2 feet squared. That's right. So I want to call the small white rectangle A1. Okay. 2 feet squared. All right. Michael, can you tell us what is the area of the big rectangle here? What is the area of the big overall rectangle? Like that entire thing?
You have to multiply all of the numbers on the outside, right?
So what do we
Not-
do?
Well, you take you take the outermost numbers, multiply those, so you get 24 feet squared.
That's it. So I want to call that A2. Okay. So I want to call that area there A2. And it's going to be 4 times 6.
So that would
And
be 22 squared.
24
feet
feet squared.
squared.
And so
Is
the
the
area
correct
of the
one.
green is simply going to be, I'm going to call that A2 minus A1, right? So as Michael said, it's going to be 22 feet squared.
Not too bad.
Lovely. Right? Didn't I say everyone has it in them to figure this out? Okay.
Yeah.
All right. Let's take a look at question 2. We want to find the area of the shaded region.
So
We're going to
this one
adopt
you
the
just find
same
the area of the
strategy
circle.
as Michael. I mean, as what Ty said.
Okay, so
What do we do in this case?
We just find the area of the circles and subtract it from the rectangles area.
All it is, okay? And actually, just to check for understanding, guys, right? Would the problem have been any different if the location of the circles were placed elsewhere?
No.
Yeah, so the location of the circle is not even important. It's irrelevant, okay? The what is relevant is the circle will take up some amount of space. So regardless of where it's positioned, it will not impact what the area of the green will turn out to be.
As long as it's positioned somewhere inside the circle. I mean, inside the rectangle.
That's right. Okay. So Emmett, what are the areas of the circle?
Well, should I use, like, should it just be 2 pi or should it be 3.14 times 2?
Let's express everything in pi because part B here says express everything in pi. So we'll just do everything in terms of pi.
So 2 pi then.
So it's 2 pi.
Wait, no. No, it's 1 pi.
1 pi. Gotta be careful.
Right, because I mixed up the radius. Wait, is it pi r squared, right?
Yeah.
So
So
it
the
is,
area of the goal will be pi. What's the radius?
wait, I don't think it will be pi, because isn't it 0.25 pi plus 0.25 pi?
Well, what's the radius of the circle?
0.5.
1/2, right? So it's 1/2. And we got to
So
square it,
then,
yeah? But
right,
then we
so
gotta
then
multiply.
1/4.
So this thing right here is the area of one circle, yeah? But we got to multiply this all by how much?
2.
Like 2.
That's it. So Ty, what's 1/2 quantity squared?
Let me see. One. Wait, man. Wait, pi. divided by 2.
No, so no, 1/2 times 1/2 because that's what 1/2 squared
So
is.
it's
Right?
one quarter.
You
One
multiply
quarter.
across. What is that?
So
Yeah, that's
so-
right. It's 1/4. So this becomes
divided by 4.
1/4, right? So it's pi
Pi over 4
4
times 2.
times 2, right? Which
So
then
that
gets to how
becomes-
much?
Pi over 2.
Pi over 2.
Pi over 2. That's it. Because 2 divides evenly into 2 times, right? So it's pi over 2.
Mhm. Yeah.
So that's the area of the circles. Okay. And then I got to figure out the area of the rectangle. Kelvin, the height of the rectangle here?
4 feet,
And the width?
10 feet,
So if I find the area of the rectangle, what?
what?
What's the area of the rectangle?
14. 14?
40. That's it. 40 feet. So I okay is the area of the overall rectangle, and the area of the holes are pi over feet squared. There's got be equal to 3 plus 2.
You subtracted, and Mr. Tan, you're pretty choppy.
I'm pretty choppy.
Oh no, you're better now. 'Cause it was lagging out on my end.
Oh, my connection maybe sometimes that happens. The connection is I guess the reason is because a lot of people are either streaming like 4K video or are like streaming video from like classes. So there's a lot of demand right around this time, I guess.
Probably the
Yeah.
first.
Yeah, those
Okay, so
it happens to me.
what was that?
It also happens to me. Like that's why I couldn't. That's why I was out of the lesson for like some amount of time yesterday because
Can we
I couldn't
continue doing the problems?
Please.
Okay. So are we okay with number 2?
Yeah, we're good.
Yep.
All right, let's move on. All right, number 3. Okay, very, very similar in this case now. Okay. Again, the position of the triangle inside of the rectangle here, it's not, it's irrelevant. Okay. We just need to know what are the dimensions of the triangle as well as the rectangle. So maybe Emmett, can you tell us what to do?
So we need to do the same thing for the last two. We just find the area of the shape and then subtract it from the rectangle.
So I want to call the area of the triangle A1. So can you help us find the area of the triangle?
So it's base times height divided by 2. So it's 2 times 1 divided by 2. So the answer is just 1.
There you go. And then the area of the rectangle. Maybe Michael, can you tell us what's the area of the rectangle?
The area of the rectangle would be. Would it be 12?
It would be 12. So therefore, the area of the overall green shaded area, right? It's just 12 minus 1, or just 11.
11.
Yep, that's all it is.
That doesn't look proportionate.
Yeah, which is why I wrote a disclaimer. Nothing is proportional, or it's not drawn to scale. So,
Yeah, for sure.
okay. So that's what it is. Okay. Moving on. This guy now. So this was what I was talking about before, about just understanding the notation, right? Emmett, what is meant by this intersection there?
That's like
What is that signifying?
the semicircle.
What about the semicircle? You're right.
that it has a 180-degree arc.
That's true. I want you to be a little more specific, right? The location of this point here, okay, is significant because it happens to be the center of
Center of multiple
of that
circles.
set. Yep, of both of these. Everyone follow that one more time?
Yeah.
Okay, so again, this guy over here, okay, is the center of the semicircle over here as well, okay? Now, upon inspection here, okay, we actually have a composition of shapes. Do you guys recognize that we actually have like different size rectangles and different size circles here at play?
Mm-hmm.
Right? Think of this like it's like a racetrack almost, right? So we actually have one side a rectangle, and then we have another rectangle inside. Okay. Sorry, guys, I'm not refreshing. Oh, here we are.
I'm seeing
Okay.
it. Yeah, we're
You're seeing it? Okay. So we have those different rectangles in place, right? And then we have different semicircles. Okay. So what we need to do, okay, we're going to adopt the same strategy, although this one's a little more complex. We'll start by maybe doing the area of this rectangle. What's the area of that rectangle? How can we tell? Or maybe
well,
not the area. Let's start by what's the width of that rectangle. Let's start there.
Width is
2.
2 inches. Yeah.
The width is 2. I like that. Okay, so the width is 2. So the width of the rectangle is 2. Okay, this is 2 right here. Okay, actually, I'll just write 2. Okay, what about the height though?
well,
It's,
we know
one.
that the radius is 1/2, so the diameter is 1.
I
That's
like
true.
that. Can you follow what Emma just said?
Yep.
Say that one more time.
So the radius is 1/2, so the diameter is 1, and then the diameter is also that side.
So the radius, as indicated over here, is 1/2, right? So therefore, this length must be 1/2. And then, like Emmett said, the diameter, which also happens to be height rectangle, therefore would have to be high. One more time. What is the height of the rectangle then?
It would have to be 1.
It would have to be 1. Very good. All right. So with that said, okay, what's the area of the rectangle on the inside?
2.
It has to be 2. Okay. So this guy in here is 2. Okay. What can we do to find the area of, let's say, the small semicircle here now?
Well, couldn't we just count the 2 semicircles as one circle and solve for it like that?
I
So that we
love
don't
that.
have to like multiply anything by 2.
So now I have 2 arrows pointing to 2 semicircles together to form one small circle, right? So what's the area of that small circle? What can we do?
Well, we know that that half of the circumference is 2 is 1/2, so it's gonna be 1. No, that's the diameter. The diameter is 1.
So the radius is 1/2. That's right. That's right, Ty. How can we find the area of the circle if we know the radius is 1/2?
Wait, isn't it the same thing as that last one?
Yeah, pretty much.
It is.
Like
What
pi
is
over
that?
2. Wait, no, it's not pi over 2. It's just pi over 4.
times.
Pi squared. Yeah, pi squared.
And what's r in this case, Kian?
Keen just got here. He left for a second.
He
Also, you
left.
muted.
Oh,
No,
okay.
I'm here.
No, he's back. He's back. He just
By the way, they finally fixed grid view.
yep.
Oh,
They
All
fixed
right.
it.
Anyways,
Very funny, Kian. Very funny.
repeat the question again.
Well, no, that's 2.
What's
No, it's
the
fixed.
radius in this case again, guys?
Radius is
It's not-
isn't it
It's 1/2.
1/2 or something? I don't know.
One, there you go. So pi is 1/2 squared. Okay.
Yep.
You have both of those. All right. So we're going to now, okay, do the same thing essentially. Okay. And what we're going to do is we're going to find the area, this big rectangle here. Okay. The overall rectangle. Now the overall rectangle is going to include that area of 2. Okay. But that's okay. But I want to find the area of the rectangle. So, Michael, what's the width of the blue rectangle?
2 inches.
2. Michael, while you're on that, okay, what do you think is going to be the height of that blue rectangle?
What would the height be? Would it also be 2?
Would be 2. That's right.
Really?
So,
Yeah, it would be.
Michael, what is the radius of the large circle here?
1.
It is 1. So to double that, we're going to get 2. So you're absolutely right. So the area of the large rectangle, which I'm going to indicate with this guy, with that arrow there, okay, that's going to be 4. Lovely. Okay. And then we're going to now need to the area of those semicircles, okay? The overall semicircle. So I'm talking about everything here. That whole green semicircle. Okay? So if we add the 2 semicircles together, what do we get? We get
You get
one giant semicircle. Oh, one giant circle, right?
Yeah, so it's 1/2 pi. It's gonna be pi squared.
It's pi times, what's the radius, Ty?
So it's pi times 1/2 squared times 2. So well, no, since we have 2 of them, that one's also going to be oh wait, no, the green one. Okay, it's going to be, yeah, it's going to be just double that.
What's the rate?
The radius
The radius
is 1.
It's 1. That's it. Times
Yeah.
pi squared. So this represents the area of one full circle. Isn't that what we have? Even though we have semicircles, but it's 2 of them together, right? So 2 semicircles together makes one whole circle, right? So that's why I don't need to do any like halving or doubling or anything like that. Okay. Okay. So now we have all this stuff. Okay. We need to find the area that's in green. So let's start by taking the area of the overall shape, right? The outer region. So the outer region, okay, is going to be pi. Whoops. So the outer region will be pi. Right? Because that's the area of the large semicircle. What's the area of the rectangle again, Michael? The large rectangle?
4.
So this represents the area of the overall. Okay, now we're going to subtract it by the area of the white regions. Okay, what's the area of the small rectangle, Kian?
The area of the small rectangle right there is
Yeah.
Isn't it 2? Or something?
It is indeed 2. Okay, so that's 2. And the area of the semicircle one more time, that's just going to be pi times 1/2 squared, right?
Mm-hmm.
And we're just going to clean up a little bit, okay? So in here, we have 2 minus pi, 1/2 times 1/2. One more time, what is that?
That's 1/4.
1/4. So it's pi over 4. And then over here, I have pi plus 4. And we're going to be subtracting them. So what's 4 minus 2, Michael?
4 minus 2? 2.
It's, and I have pi minus pi over 4. What's pi minus pi over 4?
That's 3 3/4 pi.
3 pi over, that's 3 pi over 4. Is Gabby still here?
Yes, she is.
Oh, she is. Okay. Okay. So what we're left with is is that. Okay. So that's the area of the shape region. Cool. Alrighty. So let's take a look at the next one. All right. So the same kind of strategy. Okay. You know what? Having gone through this last example with you guys, I'm going to give you guys maybe a minute. Try this around. How does that sound?
Sounds
Try to
good.
what?
Can you guys do that for me? Okay, so do that. Okay, let's take a minute. Okay, you're going to try the next one, question number 5. Sorry, my screen is refreshing. Guys, do you guys see it refreshing?
Yeah, it's frozen right now. I don't think it's refreshing. It's not.
It's frozen, right? Give me a sec.
Yep.
Your tablet isn't frozen.
It's refreshing. Well, that's the tablet, so that's a that's a good thing. I think it's the application.
Okay, now you're not presenting your screen now.
No, now he is. It says Gary Chan's presenting.
Better. Is the screen refreshed?
Now,
Should be.
Hopefully.
yeah, or no?
Yeah, I can see it. Yeah.
I can see it, but it's not moving.
Neat. This is the one aspect that frustrates me.
Now you know why I like Zoom. Now you know why I like Zoom. Better video quality.
They fixed Google
No.
Meets because they fixed grid view. Because before grid view was really glitched out, so I had to delete it and then re-downloaded it, and then they fixed it. So
I told you that's what you had to do.
now. No, but I did that before many times. I think they fixed it because they said that they upgraded grid view yesterday.
Okay.
Yeah, so I
Mr.
think they
Chair, we
fixed
can see it.
And it just upgraded
Guys,
Google
do you
Meets in
see
general.
my screen refreshing or no?
It's just the screen. It's,
Oh yeah, it's moving.
Oh
It's
wait,
moving.
no.
We see it. We see it.
We got
It works.
it. We're good. Yeah.
Do you see it refreshing? No.
Yeah.
My guy.
Yeah,
it
it's moving.
works.
See me moving it? You see?
Yes.
Yep. Woohoo.
All right, well, let's continue then. So, take 5 minutes to figure this out.
I'm going to exit out.
You said 1 minute, but
No, it was working.
no, wait, Mr. Chan.
Oh, now it's back. Okay. Okay, now it's back. All right. Okay, so
There we
let's
go.
go to this one. Okay. So hope you guys were able to find out some of these things on your own, right? What's the area of the inside here? What's the area of
rectangle
the
that is
inside?
That is
How much is that?
4.
It is
4.
indeed 4. I totally agree with that. So that area there is 4. What about the area of the rectangle?
8.
That is going to be 8. Right. Hi, can you elaborate? How do you know that?
Because we know that that this is the same value of those other like one half of the rectangle is the same value as the other half of the rectangle, the other quarters rectangle. So 2 times yeah, and we also see that there's 1 meter right here. So 2 meters times 1 meter is 2 times 4 is 8. Oh, Mr. Chen left. Okay.
Yeah, I was about to say that. In case you didn't notice, he left.
Yep,
Yeah.
we noticed.
He's
Yep.
still drunk.
Oh,
bro.
he's still presenting.
That's
Oh,
fine.
yeah,
Man.
I know.
Wait,
That's his
how?
iPad presenting. His iPad
Oh,
is
yeah.
presenting, and he
Yeah,
joined
What?
his computer.
Because his iPad is still there, and when he logged out, the only way for him to actually like log out, no, in order for him to stop share screening, he has to
Log out of
really
the
like sign
tablet.
in again, so that way he can take it out.
Okay, if you can't hear us, I'm just gonna type it in the chat. Mr. Chan,
Dude, isn't it still recording?
it's still recording, but
Yeah, it's still recording.
Oh,
This is
okay.
getting
Definitely goes
creepy
to
already.
Let's
He goes-
stop.
Relax,
This is the
Michael.
weirdest
He's not gonna
thing
say
ever.
anything stupid.
Oh, he's
Alright,
back.
anyway,
Man, where were you?
there we go.
You were creeping us out for a while.
We really
wasn't
weren't.
creeping
I think
me
you
out.
were creeped out. We weren't.
Yeah.
You were fine. Plus, you were fine, Michael.
You creep me out a little bit.
Yeah.
Not.
We weren't creeped out. We were just confused.
There
Yeah.
was negative creepage. There was negative creepage for me.
Yeah, how was that creepy?
There
You
was
just
no
wasn't there.
spook. It was creep, but there was no spook. No,
Can
No,
we
there was
focus
no
on the
creep.
lesson, please?
Okay,
Spook.
you're right.
Any
really was
Halloween related word.
Exactly.
Ooh, Halloween.
Oh boy.
Can we focus on the lesson? Like, Christ.
Yes. Okay.
I'll try to
So-
block that out of my memory now. All right.
Okay. So we have so the big rectangle is 8. We established that. So, oh, Mr. Chan, you're muted.
Mr. Chan, you're muted.
Yeah,
Can you
yeah,
hear
you're
us?
muted. You can hear us, but we can't hear him.
Okay. So guys, what's that height supposed to be?
That height is supposed to be 1.
That height's supposed to be 1. Thank you so much for that. Okay, so again, what I did not want you to do is just to make a generalization that the larger rectangle is just going to be double it. It's not always the case. Okay. Anyway, so the width is 2 and the height is 4, so therefore the area of the rectangle, the larger rectangle, is 8. The next piece here, let's find the area of the semicircle, right, or the small circles. So I have these small circles here. What's the area of those?
The diameter is 2, so the radius has to be 1.
So what's the area then?
So it's pi r squared. So pi squared. Yeah, pi.
So it's just pi.
That would be pi.
Yeah, pi.
And Emmett, what is the area of the larger circles?
So if the radius or the diameter of the smaller ones is 2, then that is just the radius of the bigger one. So the bigger one is pi 2 squared. So that's gonna be pi 4 or 4 pi.
Right. So now, in the same spirit as the last question, okay, we are going to combine the larger with the smaller, okay? So the larger circle is 4 pi, and the larger rectangle is 8, and we're going to subtract this by the smaller circle, which is pi, and the smaller rectangle, which is 4.
That's
Okay.
nice and light.
Can you help us reduce this to make this nicer looking?
So it's 3 pi minus 3 pi plus 4.
That's it. It's just 3 pi plus 4.
It's easier than like the whole pi thing of the last problem.
It is. All right. Let's take a look at the last one. Okay, so the same idea, right? What's the area of the small rectangle on the inside?
That is going to be 1.
The height is 1/2 times 2. So you're right, absolutely. The area there is 1. Whoops. The area here is 1. What's the area of the larger rectangle?
Wouldn't it be 3?
It would
No.
not be
No.
3.
2.
It would be 2, right? Because the width is 2 and the
Oh.
height is 1, right? You see that there,
Oh,
Ty?
yeah. Oh, yeah, because yeah.
Okay. Slightly trickier now. What's the area of those semicircles combined?
Whoa.
It's a quarter.
1/8.
So
Wait, no, just pi 1/8.
So what's half of 1/2?
1/4.
1/4 squared. What is
1/8.
1/4 squared?
it'd be
1/8.
1/8. Yeah, so I mean, sorry.
It's not 1/8.
It is.
Oh, 1/16. 1/16.
1/16.
Oh, right.
So it's pi over 16 in other words. Okay. And we're almost there. We have these semicircles to contend with now, right? So what's the area of those combined together?
It's one. It'll just be pi.
Pi. What's the radius? Pi?
The radius is 1/2.
1/2.
That's pi over 4. It's pi over 4. Pi over 4.
There you go.
What?
So
How do we
now
know
what we're going to
that?
do is we're going to take the larger, which is pi over 4, plus the larger rectangle.
Wait,
Does that
Mr.
be
Chan, how
that?
do we know it's 1/2?
How do we know what is 1/2?
Yeah, how do we know that?
Because the whole thing, the whole height is 1 kilometer.
Oh,
That's right.
yeah, I forgot about that.
Then subtract it by the area of the smaller, which is pi over 16, minus, plus 1.
1.
Yep. So
Uh,
we're going to clean this up. Emmett, can you help us out with that? How do I do pi
Yeah,
over
yeah.
4 minus pi over 16?
You got to make it 4 pi over 16.
So it becomes how much?
Wait, like you want me to combine the pies? So
Yeah,
now
can
it
you do that?
becomes 3 pi over 16.
Good. Then 2 minus 1 just gets us 1. So it's plus 1. So this right here is the area of last problem. Here you go. Here's everything in its entirety again.
And then tomorrow is the season finale of remote learning.
Almost
Yes,
dead.
true enough. What Emmett said.